This is section B of ICSE Chemistry Sample Paper from the Council for 2023. I have already posted section A fully solved. Now let us come to section B. In section B, we have to attempt any 4 questions out of total 6. So let us look at question 3. Question 3, first subpart. Identify the anion present in the following compounds. So we have barium chloride is added to the solution of compound B and white precipitate which is insoluble in dilute hydrochloric is formed. Now barium chloride will form white precipitate if there is sulfate radical or sulfite radical. But if it is insoluble in dilute hydrochloric acid, then it is going to be sulfate and not sulfite. So your A anion is sulfate, and into bracket you will write SO4 2-. Let us come to B. When dilute sulfuric acid is added to compound B, a gas is produced which turns lime water milky. Lime water milky means it could be CO2 or SO2. Now it has no effect on acidified potassium dichromate, means it is carbon dioxide. So if it is carbon dioxide, it will have to have carbonate as the negative radical in compound D. We got the answers, we write them like so. Write the products and balance the equation. Now sulfur and HNO3 gives H2SO4 plus H2O plus NO2, which is a gas, and this is the balance reaction. ZNS plus HCl, it has to be dilute and we will get ZnCl2, so we will write 2 here and we will have H2S, which is a gas. Let us come to the third one. Arrange the following as per instructions given in the brackets. Now what do these look like? These are arranged in increasing order of electronegativity. So if it is period 3, we'll have sodium, then we'll have Si, then we have S, then we'll have Cl, and we will have K here. Now increasing order of negativity, this is going to be from NaSi. This is more electronegative if we go to the right side. But if we go down, this is going to be more electropositive in nature. So it is going to be like so. So how do we write the order? It will be increasing order, means you will start with the electropositive and go towards electronegative. So we'll have K, then Na, then Si, then S, and then Cl. Here we have the second set of elements, increasing order of metallic character. To begin with, let us just arrange them properly according to period 2. It is Li, then B. So this is the order 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now metallic character will be like so. Lithium is metallic, this is non-metallic. So the correct order for this will be F, then O, then N, then C, B, Be, and Li. We come to C. Br, F, I, Cl. These are halogens, increasing order of atomic size. Now atomic size is going to be like so. So you'll have fluorine, then chlorine, then bromine, then iodine. So increasing size would be first F, then Cl, then Br, and then I. Okay, so that finishes our 3 marks of third subpart. We continue with question 3, fourth subpart. Fill in the blanks. In a covalent compound, the bond is formed due to the sharing of electrons. A molecule which has a single lone pair of electrons will be ammonia and not water. Water has 2 lone pairs. If you do not remember the structure, just quickly look at your textbook and see what is the structure. Electrovalent compounds do not conduct electricity in solid state, because in molten the ions become free. In solid they are held together by strong electrostatic force of attraction. Now remember, in this section B, we have to attempt any 4 questions. So if you feel that you are okay with 3, go ahead with 3. Let us look at our 4th question. First subpart. In each of the substances given below, what is the role played in extraction of aluminium? Now remember, cryolite, the 3 functions you have to remember by heart. It is going to lower the fusion temperature from 2050 degrees C to 950 degrees C for alumina. And next one is going to increase the conductivity, and next one it is going to increase the mobility. And then we come to graphite. The role played by the graphite is it acts as an anode. We come to second one. Calculate a gas cylinder filled with hydrogen and it holds 5 grams of gas. The same cylinder holds 17 grams of gas X under the same temperature and pressure. Calculate the vapor density. Now remember, the vapor density formula is, so it is the ratio of mass of certain volume of a gas upon mass of the same volume of H2 under the same conditions of temperature and pressure. Now hydrogen is 5 grams and the same cylinder holds 85 grams of gas X. So you will see vapor density is 17 and we are asked the vapor density only. So this is our answer. They could have also asked you what is the RMM, that is relative molecular mass of X. If they had to ask you this, then what we would have done? We would have done 2 into VD, that is 2 into 17, that is 34, we could have said. Okay? Give the empirical formula for this. Now what is the empirical formula? It's the simplest ratio of this. Now how many C's do you see? There are 2 C's. How many O's do you see? There are 2 O's. And how many H's do you see? There are 4. So this is actually the molecular formula. You are going to first say C is to H is to O is going to be 2 is to 4 is to 2. So that will give us 1 is to 2 is to 2 as the simple ratio, and therefore your empirical formula is going to be CH2O. We come to third and the fourth subpart now. Following questions are pertaining to the laboratory preparation of hydrogen chloride gas. Write the balanced chemical equation for the preparation, mentioning the conditions. Now for HCl, we are going to take rock salt, that is NaCl, and then we are going to take sulfuric acid, which is concentrated, and we are going to have less than 200 degrees C, which is the condition, and we are going to get NaHSO4, which is the acid salt, and we will get HCl, which is in gaseous form. So we have written this along with the condition. Now if they say mention the condition, you could write separately condition that the temperature should be less than 200 degrees C. Why is concentrated nitric acid not used in preparation of hydrogen chloride gas? Now nitric acid is a volatile acid. It's got a boiling point very low, and that is why hydrogen chloride also is volatile. You cannot use a volatile acid to displace a volatile acid. So in place of H2SO4, if we were to use HNO3, it will volatilize out along with this, and we will not get HCl as the only gaseous product. So we say nitric acid is a volatile acid. That's the key word. Hence we cannot use to displace a volatile acid like hydrochloric acid from its salt. How is hydrogen chloride gas collected? It's heavier than air. So it is collected by upward displacement of air. Explain the following. Explain the following means give reasons. A. Concentrated nitric acid appears yellow when it is left standing in the glass bottle. Here we have to know that nitric acid is photosensitive. So in presence of light or when it is left to stand by itself, it is going to decompose. So how do you mention this? When left standing, it decomposes slowly, liberating reddish brown nitrogen dioxide gas which dissolves in the nitric acid and it imparts yellow color to the acid. Okay, let us come to B part. An inverted funnel is used to dissolve hydrogen chloride gas in water. Now the inverted funnel, what happens? HCl gas is highly soluble in water and it causes back suction and the glass apparatus tends to crack because of the vacuum created. Now inverted funnel increases the surface area and minimizes or prevents back suction. So we have to mention all that. What I have written, that hydrogen chloride is highly soluble in water. If you want, you can mention 452 volumes in 1 volume of water and causes back suction when dissolved in water with a tube. But with inverted funnel, the back suction is minimized or prevented and the apparatus does not crack, thus better dissolution takes place. C. All apparatus made of glass is used in the laboratory preparation of nitric acid. Now you will say this is so as nitric acid vapors are highly corrosive and they attack even the rubber and the cork and therefore it will be safer to use all glass apparatus. So finished 2 questions. Question 3 and 4 are done. Now question number 5, first part. State one property of ammonia demonstrated by fountain experiment, and that is ammonia is highly soluble in water. Give the ionic equation when ammonium hydroxide is dissolved in water. So NH4OH, because it is NH4 plus and OH1 minus in presence of water, it is going to give us ionic equation means NH4 plus ion and OH1 minus ion. Come to the next one. Name the probable cation present based on the following observations. Reddish brown precipitate insoluble in ammonium hydroxide. Now this will have to be ferric, right? So Fe3 plus and you will write it as ferric ion. Blue colored sulfate solution will be copper cation, so that will be Cu2 plus and what we will write is copper 2 plus ion. Or you can mention that the cation is ferric ion and here you can say the cation is copper 2 plus ion. Give balanced chemical equation for the following. Laboratory preparation of methane from sodium acetate. Now sodium acetate is CH3COONA plus we take soda lime which is like so and we have to heat this and we will have Na2CO3 plus CH4 which is a gas. So this is our first balanced equation. Preparation of ethyne from 1,2-dibromoethane. 1,2-dibromoethane, we will write it like this with Br here and Br here. There will be one hydrogen here and here, one hydrogen here and here. And I'm going to take 2KOH alcoholic and I'm going to boil. Now when we boil this, we will have 1 kBr and 1 kBr. So that will be 2 kBr and then 1 H and this OH like so. So we will have here C triple bond C will be formed. So C triple bond C with H, this is your ethyne. I'm writing here ethyne. Plus we will have 2 KBr and plus we will have 2 water molecules. So this is the reaction for preparation of ethyne from this 1,2-dibromoethene. Ethene reacting with chlorine. Ethene is C double bond C. This is your ethene and it is reacting with chlorine, and the condition over here is CCl4 inert solvent. And we will have this chlorine getting attached here. So we would have like this chlorine and chlorine getting attached, and this is how we will get our 1,2-dichloroethane. So we finish with the third part and now we come to the fourth part. State one relevant observation for each of the following reactions. A. When excess ammonia is passed through an aqueous solution of lead nitrate. Now excess ammonia through the solution means it's going to become NH4OH. What is lead nitrate? Lead nitrate, PbNO3 twice, will react with NH4OH. Now if you do not know the observation properly, just write the reaction. You will automatically get to know the reaction if you study properly. You must know that Pb will take this OH and it will become PbOH twice. So here it's going to be the observation chalky white precipitate, I'll just write PBT, of PbOH twice is formed, which is insoluble in excess NH4OH solution. Copper sulfate solution is electrolyzed using copper electrodes. With copper electrodes, remember, they will be taking part in the reactions, they will be active electrodes and they will supply copper cations into the solution. So for B, our observation will be blue color of electrolyte does not fade. Ammonium hydroxide is added to ferrous sulfate, so it will become ferrous hydroxide. Ferrous hydroxide means dirty green precipitate of FeOH twice is formed, which is insoluble in excess NH4OH solution. Now this is again 10 marks finished. So question 5 finished. We finished 3 questions. We have 3 more to go to solve the entire paper. But remember, for your examination, you need to solve only 4 questions. Now question number 6, define. Now you need to learn Gay-Lussac's law and also vapor density. Just learn this up by heart, okay? Now second one is solve. So we have 1250 cc of oxygen was burnt with 300 cc of ethane. Calculate the volume of the unused oxygen and the volume of the carbon dioxide formed. So let us write the reaction first. We'll have ethane means C2H6 plus oxygen, and that will give us CO2 and plus H2O. Let's balance the reaction. Now oxygen was 1250 cc and 300 cc of ethane. We have to find the volume of unused oxygen and the volume of carbon dioxide formed as well. Okay, so here we will write 2 volumes is to 7 volumes gives here 4 means 4 volumes is to 6 volumes, and this is because of Gay-Lussac's law. Now if 300 cc's are going to be 2 volumes, so one volume is going to be 150, so I'm going to write 2 into 150 and I'm going to write cc here. Now that is 300, which is matching with this, right? Is to here, if each volume is 150, then 7 into 150 cc will be here. That will have 4 into 150 cc will be here is to 6 into 150 cc will be here. Okay. Now we are asked the unused oxygen. So we will say volume of oxygen used will be 7 into 150, that is 1050 cc. Therefore, volume of unused O2 will be 1250 minus 1050. And how much is that? From this 1000 is gone, so that is 250, so that will be 200 cc. So this is your answer 1. Now the volume of CO2 formed is going to be 4 into 150, and that is 600 cc. That is your answer 2. Okay, so this was also for 2 marks here. Let us look at our next question. State the conditions required for the following reactions: conversion of SO2 to SO3. Now here you will have the catalyst. Catalyst is vanadium pentoxide, correct? Temperature is 450 degrees to 500 degrees C, and the pressure is 1 to 2 atmosphere. Now we come to the next one, conversion of ammonia to nitric acid. For this again we will have catalyst is platinum and the temperature is 700 degrees C to 800 degrees C. Then we have conversion of nitrogen to ammonia. For this we'll have catalyst, that is finely divided iron. We have promoter. Promoter is molybdenum. Temperature. What is the temperature? 450 degrees C to 500 degrees C. And the pressure. What is the pressure? It is 200 to 900 atmosphere pressure. So you will see, like, although we had to write so much, each one of them is for 1 mark each only. Now we come to the fourth subpart of question 6. Choose the role played by concentrated sulfuric acid as A, B, C, which is responsible for reaction 1, 2, 3. So oxidizing agent, this and this. Where is the oxidizing agent being used? Here in this. So this is your A. Non-volatile acid will be here. So this is your B. And this one is where dehydration is happening. That is a reaction C. So you will write your 1 as B, 2 as C, and 3 as A. Now finished 4 questions. So basically we have finished 80 marks, but yes, we will complete question 7 and 8 as well. Number 1, find the empirical formula and the molecular formula of the organic compound from the data given below. C is given here, H is given this way, N is given this way, vapor density is 39.5. So let us see how we write it down. So I have made the tables over here. Can you see? This is the element carbon, hydrogen, nitrogen. The percentages I have written, atomic weights are written over here, relative number of atoms are written over here. That is this percentage divided by atomic weight, then this percentage divided by atomic weight, and this percentage divided by this atomic weight. So you can see the calculations. This comes out to be 6.32. This is 6.32, and nitrogen I have shown here this side 1.26. Now we get the simple ratio by dividing each one of these by 1.26. So you will get this 5 times as you can see in the calculations over here. It is 5 times it has gone, and so we get the empirical formula as C5H5N. And the empirical formula weight will be, when we calculate, it will turn out to be 79. Then we need to find the value of N, which is RMM, which is molecular formula weight, which is 2 into Vd into Vd, that is 2 into 39.5, which has been given to us, upon empirical formula weight, which is 79. You multiply these two, you get 79. 79 upon 79 equal to 1. So our molecular formula is N into empirical formula, and we write so. We get the molecular formula as C5H5N, and that is our answer. Now we come to question number 7. Identify the functional group in the following organic compounds. The functional group over here is -CHO, and this is aldehydic group. And the formula for that is -CHO. Here the functional group is -COOH, which is carboxylic acid group, and that will be given by -COOH. So can you see how simple this was? Only this was a little bit annoying, right? During electrolysis of copper to sulfate solution using platinum as cathode and graphite as anode. Now platinum as cathode will have copper getting deposited on the platinum, and graphite as anode. So graphite is inert, which means it is not going to take part in the reaction. What will we observe then? The copper 2+ ions which will get deposited. So at the cathode, copper, that is pinkish brown metal, is deposited. State the change noticed in the electrolyte. The blue color will fade. Why it will fade? Because graphite, which is inert electrode, is not going to take part in the reaction like when it was with copper electrode, and therefore the Cu2+ ions in the electrolyte will decrease and they will make the blue color fade. Write the reaction at the cathode. At cathode, Cu2+ will migrate. They will take 2 electrons and you will get Cu neutral atom. Let us look at the fourth one. Choose the answer from the list which fits the description. A basic oxide. Where is the basic oxide? CaO is the basic oxide. The oxide which is acidic will be the non-metallic. So CO2 or CO. CO is neutral, CO2 is acidic. And an alkali will be NaOH. Why this hydroxide will not be an alkali? Because this is insoluble. So it cannot be alkali. Now we come to the last question. With this we have finished actually full 100 marks. But this is for your information about how the questions will be asked. So this will be the last question. Draw the electrode dot structure for the following. Now this and this, I think you can take straight from the book. We don't need to show it just now. I will just guide you for the second one. Distinguish between the following as directed: sodium carbonate and sodium sulfate. We have to distinguish. Now here, using dilute HCl, if you are adding to this and this dilute HCl, this is going to give you CO2 and this is not going to give any reaction. So we'll say that if there is brisk effervescence of colorless, odorless CO2 gas, which turns lime water milky, but has no effect on acidified potassium dichloride, then it is CO2 gas. Therefore, we will say CO3 carbonate radical is present, therefore sodium carbonate present. And under this we will say if there is no reaction, then sodium sulfate present. Okay, so we can just do this very fast. Ammonium sulfate and sodium sulfate, both of them are sulfate. So what is different? Sodium and ammonium. Now if we take calcium hydroxide, we will get sodium hydroxide and here we'll get ammonium hydroxide, correct? But that ammonium hydroxide is going to release ammonia. So we will say that if pungent smelling ammonia gases evolve, and what is the test for that? Which gives dense white fumes of ammonium chloride when a glass rod dipped in conch HCl is brought near it. Name the particle present in strong electrolyte. They will be almost all ions. And if it's a weak electrolyte, then it will be ions plus molecules. And if it is non-electrolyte, it will be molecules. Now we come to this last one. An element X has atomic number 17. So 17 means the electronic configuration is 287. State the period and the group. So it is period is 3 and the group is group 17 or 7A. Is it a metal or a non-metal? Obviously it is a non-metal. Why is it a non-metal? Since it has got 7 electrons, 4, 5, 6, 7 electrons, means it's a non-metal. Write the formula between X and hydrogen. Now X and hydrogen. Now X is your chlorine and hydrogen, so it's going to be HX, like HCl. This is chlorine, right? So this is how we finish our entire paper. So now you know that although in the second section we are supposed to have solved 4 questions, we have solved all 6. And now you see how easy it can be, provided you remember every tip and trick that was listed over here. Now that you have solved the sample paper, the specimen paper that has been given by the ICSE Council, I'm sure you are all well prepared. Do your best and get full marks. All the best. Bye.